Nice. Good. And Luis, welcome back. How's it going, Luis?
Hello, Joshua. I'm fine, thank you.
Nice. Good to hear. And Luis, what are you gonna do tomorrow?
I don't have plans. I
All
will
right.
just study English, play guitar. You know.
Nice. What do you like to play on guitar?
I like Brazilian music, uh,
Okay.
uh, some international as well.
All right. Very
Uh,
nice. And Esti Oriz, welcome to class. Esti, how's it going?
Hi, Joshua. No,
No?
and all,
Oh, and all. Okay.
and all.
How's it going? How are you?
Fine, thank you.
Yeah. I thought you just answered no. All right. What are you gonna
Hmm.
do for the weekend? What are you doing?
I have booked a course for the weekend, so I'm going to attend that classes.
Okay. Good. Very nice. And Vitali, welcome back. Vitali, how are you?
I am fine as always and mathematical.
Very mathematical. Um, Good to hear. Um, and yeah, like I said, welcome back. Susanna, how's it going?
I'm fine, teacher. Thank you.
Nice. Susanna, what about you? What are your plans for the weekend?
Well, today I'm going to a festival with my friends and my husband. And well, for tomorrow, I don't have plans.
Okay, no plans tomorrow, but today, festival. All right.
Yeah.
All right, good. And Rabi, welcome to class. Rabi, how's it going? Rabi, are you there? Okay, maybe not. All right, I think we're good. Let's get started on today's class. Let's start with Alexander. Can you read the title and the next lines?
Mhm. Today we will not do any math problems, but talk about math.
Good. And I think that actually might be a lie. We might do a few math problems, but hopefully not too many. Alexander, can you ask Jen?
Uh, Something on background. I, don't, I didn't recognize what is it.
I think we're looking at Ravi.
Or,
All right, perfect. Yeah, go ahead.
uh, do you like math? Why not? I don't know exactly if I like math or not like, because I remember when I studied at the university, math, I didn't like mathematics, but now in my life, in my when I am on work, I use some math equations in to solve some problem to anyway I use it in business.
Nice. I use it in business.
Mhm.
All right. Well done.
But
And
often it's boring.
okay, but often it's boring. Yeah, I'd agree. Sometimes it can be boring. I use it when I'm at work as one of the prepositions that I would change. But yeah, I think you did a good job. All right. And so, Alexander, can you ask Luis the next question?
Mm. Luis, what is your favorite or least favorite type of math? I mean, algebra, geometry, or
Uh,
something.
I I must say that I find geometry. Uh, I like geometry in algebra.
Okay, good. Do you think
Yes,
you prefer geometry or algebra?
it's hard to say. I just algebra is easier for me, but I admire why I really envy who demand the knowledge of geometry. I would
Okay,
like to study more. Yes.
maybe those who I really envy those who know geometry well.
Yes, I think
Okay.
it's beautiful when somebody solve a geometry problem.
Yeah, geometry is really pretty, for sure. Good, really good answer. And Ilkin, welcome to class. Ilkin, how's it going?
Hi, teacher. Thank you. Everything is okay.
Okay, good to hear. And all right, yeah, I think we're good. Uh, Rabi, are you there? Your microphone is muted, but are you there? Hmm. Okay. Maybe not. Let's go on to the next page. And let's have Mustafa. Can you read the title and the words?
Okay, teacher. Plus, minus, times divided by, times and divided by. Problem, percent, numerator, denominator, fractions, fractions, decimal, calculate, exponent, exponential,
Good.
calculate,
Okay.
yeah.
It's a little bit different. So let's start at the bottom. Let's start with exponent.
Okay.
Exponent.
Exponent,
And then exponential.
exponential,
Good. Then calculate.
calculate, um,
Calculate.
Calculate,
okay.
calculate,
Calculate.
Calculate,
Calculate.
calculate,
calculate,
Calculate. Yeah. And
calculate.
then, good. Decimal.
Lesson.
decimal,
Nice job, Mustafa. Denominator.
denominator,
Good. Denominator. Numerator.
Numerator.
numerator,
Percent.
numerator, numerator,
And percent.
Percent.
percent,
Yeah,
Percent.
percent.
percent,
A long letter
Yeah.
V.
And that T is kind of swallowed as well. We can say percent.
percent.
Uh-huh. Good job. Okay, and does anybody have any questions about any of these words?
I have
Uh,
one. Uh,
sorry.
okay.
I don't understand the definition of vocabularies. For example, something. For example, numerator, denominator, decimal, and exponential. Also problem. What does it mean problem in the mathematics?
Okay. And also, there was another question. Who had also had a question?
I have one, but I told that next times.
Okay. Okay, so let's look at numerator. Does anybody know what a numerator is?
This is the thing what we are divided.
Yeah, so the number that's divided, the
Yeah.
top.
Can I explain like 3 per 5 maybe? So 3 is numerator and the denominator is 5.
Yeah. So if we have 3/5,
Teacher, boson is down.
I didn't quite hear you. Can you repeat what you said?
Um, I say that if boson, the meaning of boson is down.
Yes, the bottom number is the lower number. Yeah. Okay. What's a decimal? Okay. So if we look at 1 point.
Decimal is like the number after the point.
Yeah, so these are decimals. This is a decimal point, and the numbers here are decimals.
345 is decimal of this figure.
Yeah, that's the decimal. And this is the decimal point.
Decimal point. Okay.
Yeah, okay, and
Exponent.
yeah, does anybody know what an exponent is?
Can I try?
Yeah.
Yeah, exponent is any number when you times by 10, any number. I can say like you can say 5 times 10 power 5, I guess.
Okay. Yeah, so can't actually do that on my computer, but we can do it like 5√3. So it's any number times itself to a certain number of times. So if we have 5, sorry, 5 to the third power,
Yeah.
which is an exponent, and so the exponent would be 3.
Okay, exponent.
And yeah, so if you have 5 times 5 times 5 times 5 times 5. So what would be the exponent here?
Exponent 5.
Yeah, 5 exponent 5. Yes,
5
6
exponent
actually.
6 is 6.
Yeah. Yep.
6.
And it's expressed by that.
Okay. And exponential? Exponential.
Yeah, so that's talking about a type of growth or decay. So anything that's exponential, on a graph, it looks like this. So it starts out small, and then it increases rapidly or decreases rapidly. And so we can use it in everyday speech by like, oh man, you've grown exponentially since I've seen you last. It's just kind of like saying a lot. But this is exponential growth and decay. But yeah, so we use it in everyday speech about a lot more than just math. So exponential is a really common word. So, oh man, you guys have been increasing exponentially. Things like that. Or exponential growth in a business. Any other questions here?
Yes, my question. Joshua, I tried to talk with Siri on the iPhone. This is an iPhone assistant.
Yes.
And say that 2 times 2. And she doesn't understand. She understands 2 multiplied 2. What's the difference between times and multiplies?
Times is more common. So 2 times 2. Maybe it's just because you've got a Spanish Siri?
Oh,
I don't
no,
know.
no, no, English.
Yeah, 2 times 2 would be much more common in everyday speech, in math, pretty much everywhere, maybe except for just Siri. I don't know. That
Okay.
sounds very strange. I don't know why she wouldn't recognize that. Good
And
question, though.
Teacher, problem is remaining, which you didn't explain. Sorry.
Ah, problem is a problem. Okay, does anybody know what a problem is?
Rabi wants to try.
Yeah, go for it.
Yeah, problem is in a mathematical equation or calculation that you're supposed to find the solution of it.
Yeah. So it's like an equation that you need to find the solution for. Would be a problem, for sure. So pretty much just any unsolved math equation. Yeah. And Ravi, it looks like your
Teacher,
internet's working a little
teacher,
bit
I
better.
had a question about when it's a fraction, when you had one number and other two.
Yeah.
When you have one number?
I wrote in the chat because I don't know how to explain.
Okay. 3 and well, so that wouldn't really work because you have to solve. So 6 over 2 is just 6 divided by 2, which equals 3. So if you have 3 and then like 6 over 2, it's 3 times 3 maybe, but it depends on how you write that. Also, yeah, if we could try to write in the other chat box, I don't know why, but the Verbling chat box doesn't really work too well for me. I always am missing what's written at the bottom. So if we try this chat, that seems to be working better, just the group chat. Yeah, does that make sense what I'm saying, Susanna?
For example, when you had one number, for example, 5, and a fraction. For
Okay, so
example, 2 divide 4.
yeah,
This is
so
the
that would
example.
be 5.5. So because 2 divided by 4 is just a half, because you need to reduce the fraction. So
Yeah,
that's
you have a
5.5.
fraction, another number. It's a mixed fraction.
Yeah, but so pretty much what that number means is just 5.5, expressed in decimals.
I don't understand. For example, in Mexico, this fraction you can read 5 enteros, 2 cuartos. It's in Spanish, but in English, I don't know how can I say 5 enteros. It's only 5, or I don't know.
Well, so 5 and 2/4, 2/4 is what you'd say there, but 2/4 isn't really a thing. You just say 5.5, or 5 and maybe 3/5. Those are kind of the ways that you'd read those fractions. Does that make sense, Susanna?
Okay, teacher, thank you.
Okay. And Rabi, so back to you. Rabi, so where are you from?
I'm from Tanzania.
Right. And am I pronouncing your name correctly, Rabi?
Tanzania?
Am I saying your name correctly? Rabi?
Yeah. From Tanzania.
Okay. Maybe. Yeah. All right. And Giulietta, welcome to class as well. Giulietta, how are you?
Hi, I'm fine, thank you.
Okay. Nice. Good to hear. Good to see you again.
Thanks.
And does anybody have any other questions about any of these words? Let's skip that for now. Let's go back actually and try this role play. And I think we're with Susanna. Susanna, can you read the role of the teacher? Susanna,
Yeah, teacher.
can you read the role of the teacher?
Okay, teacher. You are collecting math homework. You wonder if the students even knew the topic of the homework, multiplication, division, etc.
Good. Okay, and so division.
Okay,
Division.
division.
Good. And then when we say etc., it's often mispronounced as etc. That's a mispronunciation. It is, because it's from Latin, it's etc. Can you repeat etc.?
Etc.
Yeah, good.
And is division. Division.
And good. Vitali, can you read the role of the student?
Yeah. Student, you don't have your math homework. Make excuses. My
Good.
best.
And Susanna, how would you start the conversation as the teacher?
Sorry, teacher. Okay, I'm the teacher.
Yes.
Okay. Student, where is your homework?
Nice. Vitali, how would you answer?
Okay. Dear teacher Joshua, I'm completely honest with you, and my homework eaten by my dad.
Completely honest with you. My homework, past progressive or past perfect?
That's perfect. Have eaten by my dad.
By your dad. We might
My,
actually was eaten. It'll be
okay.
passive voice. Was eaten by my dad.
Yeah.
That's ridiculous. All right, Alexander, how would you answer?
Huh. Are you kidding? Um, do you mean that your father always eats your homework?
Always your homework. We're missing something out on eat.
Eats.
Yes, good. And Julieta, how would you respond?
No, just math homework.
Good. Ilkin, how would you respond?
Uh, no, just mathematics homework. Uh, you are not doing your homework every time. Or how can I say? Why? You are lazy student. Lazy people.
Okay, you're a lazy student. All right, Mustafa, how would you respond?
You are not doing your homework all the time. Why? I am I mm, I just forgot it. I just forgot my homework today. I always uh doing my homework. Do my homework.
Yeah,
Do my homework. Yeah.
the correction. Okay. And Susanna, how would you respond?
Mm, Please, don't lie to me. You every day forget your homework.
You every day forget your homework?
Yeah.
Okay, we need to
And
reorder this.
what?
Oh, shoot. We need to reorder that. Just change the order of it.
Before you forget your homework every day?
Yeah, good. You forget your homework every day?
Yeah.
Perfect.
Okay. Don't lie to me. You forget your homework every day, and you always uh, invent a story for that.
For it,
Correct.
maybe. Okay, good. Vitali, how would you answer?
Teacher, I know I am always lying to you, but now it's really happened.
Good. And Alexander, how'd you respond?
Mm,
Okay, go to the blackboard and try to solve the problems.
Okay. And Julieta, how'd you respond?
right now, in front of my classmates, I am
Nice.
shy.
Yeah. Good. And Ilkin, how'd you respond? Ilkin? Ilkin, are you there? Okay, Mustafa, how would you answer? Mustafa?
Aha, benim bağlam.
Can you guys hear me?
Yes, I can hear you.
Okay, Ilkin, how would you respond?
Uh, uh, if you didn't want like this, you had to do your homework.
Sorry, if you... What?
If you don't want this attitude, you have to do your homework.
Don't want this attitude? Is that what you said?
Nothing, only this.
I'm not exactly sure what you mean.
Uh, Teacher says that go to the background and try to solve the problems. Background, blackboard. Okay, in our country, sometimes if the student doesn't do his or her homework, teacher takes the child on the corner of the room.
The teacher does what?
Teacher takes the children, the student to the corner of the classroom.
Oh,
Okay.
Okay, and it's a shy position.
Okay, so kind of like a dunce cap?
I understood like this. That's why.
Okay. Okay, so do you know what the blackboard is in this case?
Okay, blackboard. Okay.
Yeah, so he needs to go up to the blackboard and solve the problems. And he's saying, right now in front of my classmates, I'm shy. I don't want to do the problems in front of them. So how would you answer there?
Don't be shy. Don't be shy. Don't be shy. You have to do your homework yourself.
Okay, so you have to do your homework or prove that you maybe know how to solve these problems. So yeah, like maybe that's what he'd be doing up at the blackboard is proving that he knows them. Susanna, how would you respond?
Um, okay, teacher, I'm going to try to solve the problems, but uh, I promise that tomorrow I'm going to do my homework.
Okay, good. And Vitali, how would you answer?
It is enough.
Um, I'm so tired from your excuses. Now I'm going to the principal.
Okay, I'm going to the principal.
And bring the debt with you. Bring your debt with you.
Excuse me?
And take the debt with you. Oh my God.
I'm not sure what you mean.
Uh, okay, I spelling in chat.
Okay.
How's the father?
Your dad
Yeah,
to
it's
the
my father. My father.
to the school for solving your problem.
Oh, okay. So
I will say something to your father or your dad
Yeah.
about you.
so you're going to the principal and take your dad with you.
With your homework,
Yeah.
of course.
Okay, because he ate it. All right, I think that works for sure. Let's finish up with this. Does anybody have any questions here? Okay. Let's do just a little bit of reading. And let's start with Alexander. Can you read the first part of this?
Okay. Clearing out all that snow as quickly and cheaply as possible requires choosing the most efficient routes. One with no black tracking uh, uh, scenic routes. And how do you do that? Math, writes Marcus Wu in Wired. Math that's also used to most efficiently deliver mail and pick up trash for city residents. In the 18th century, mathematician Leonard Euler provided that one could find a route across all the bridges uh, connecting islands in Königsberg, just once without doubling back. But his solution required that every intersection consist of an even number of rows. That sure doesn't apply to Boston, where many roads end in a T or suddenly turn one way. So how to most efficiently plow to the over 100 or snow in the city? In 1962, Chinese mathematician Meiko Quan introduced the problem in the general case with both even and odd intersection.
Good. Okay. So a couple things. So backtracking.
Backtracking.
And then scenic.
Scenic.
Roots?
Just roots. Roots.
Yeah. In British English, I think it'd be more like routes. But American English, we'd say roots.
Okay.
Trash?
Trash.
Mathematician?
Mathematician.
Yeah, mathematician. Euler?
Euler. Euler.
Bridges?
Bridges.
And plow?
Plow. What does plow mean? I don't
Hey,
know.
Julieta, what does plow mean?
Plow means to make to open the snow,
So, to open a path in the snow?
to open a path in the snow.
Yeah. So we can also, plow the earth. So if you kind of open a path in the earth to till the earth to move it around so you can plant things in it. So you plow the earth, you plow snow. Yeah, it's just kind of pushing it out of the way. Yeah, you can also plow into things, which is just running into things, which is a little bit more colloquial. So not in this context, but good. And then 100 inches. 100 inches.
100 inches.
Yeah. So those two lines equals inches. And Chinese.
Chinese.
Good. Julieta, can you read the next part?
Okay. He called it the postman problem and proposed a solution, but there are further complications. Priority is given to major arteries. There are multiple snow plows and salt trucks at work, and cities want to avoid having to pay overtime wages to the drivers. But you don't need the perfect solution, just one that gets the job done, concludes Hu. So engineers can break the problem down, for example, by dividing a network of streets into smaller networks that they can tackle individually, using the Postman algorithm, for example. The City of Toronto uses ArcGIS software that incorporates all the variables and automatically splits out its route, which has saved some money. The Boston Mayor's Office at New Urban Mechanics is using math algorithms and software to find the best way to clear the street of this
Oh, sorry.
season's record-breaking snow, with inconsistent success.
Good. Inconsistent.
Inconsistent.
Good. Algorithms.
Algorithms.
Good. Mayors.
Mayors.
And then tackle individually.
Tackle individually. No, individually.
Yeah, so individually. Kind of like that, individually.
Individually.
Good. Well done, individually. Okay, and does anybody have any questions on this part?
Okay. What is the ArcGIS software?
I know that.
Yeah, I don't know. It's some sort of software that
It's a software that helps you to make maps by using many layers of dates, and you can do everything because you can make zone by with a weight of something, and so you can extrapolate We call it urban zonization, something like that.
Okay, thank you, nerd girl. And this is like you have to know answer. It's like okay, I got it. Thank you.
Good job. I can't believe you actually know what ArcGIS software is.
Oh yes, I have used a lot.
Okay.
Did you use AutoCAD Civil 3D?
What?
3D. AutoCAD Civil 3D?
Yeah. Yes, I don't like it. But I have used it.
Oh my god, I love.
Good. Any other questions? Okay. Yeah, I guess maybe Alexander, can you talk or can you tell us what they're talking about in this reading? What's going on?
The problem is when someone needs to pass from point, for example, from point 8 to point 2 in many different ways. When someone has many opportunities, but this solution may differ from each other when we talk about time and duration of this movement. And the problem is to make algorithm that helps people or transport to deliver, for example, products, or to, in this case, postman to achieve your destination in most in the shortest time.
Yeah, in the most efficient way, we might say.
Yes.
Yeah. Good. Yeah, I think that's perfect. All right, and yeah, I think that's good. Let's go on. Yeah, let's have Julieta. Can you read the title?
Identify the symbol. Tell when it is used.
Good. Can you try the first one?
Multiply or times by.
Multiply by or times.
Ah, okay. Multiply by or times.
And can you make an equation using it?
2 times 5 equals 2.
Equals what?
Equals to them.
2 times 5 equals...
Equals 10 without 2.
Yeah.
Okay.
I could have sworn you said equals 2, but good. 2 times 5
Okay. Okay.
Good job. Vitaly, what about the next one?
The strange hieroglyphic. This is divided.
Mm-hmm. Need a preposition after divided.
2. 3, 4. I don't know.
A preposition.
On?
Not quite. It's the same preposition that's followed by multiplied.
By.
Wow.
Divided by.
Uh-huh.
Or you could also call it a division symbol. And can you make an equation using a division symbol?
1032 divided by 0.
Okay, good. Divided by 0 equals what?
Black hole, I think. Or disaster.
Good. Okay.
Honestly,
black hole.
honestly, this was limited of zero of infinity.
Yeah.
Yeah, I'm there too.
Infinity. I don't know how to make the infinity symbol, but yeah, that was good. Alexander, what about the next one?
Next one is the square root. As example, the square root from 25 equals 5.
Not from.
No, of.
Yeah. So we'd say the square root of a number. So the square root of 25. We probably also say is. So equals and is usually interchangeable. Yeah, but just when we're talking about square roots, like it is 25. It wouldn't really equal 25. Just because it's not really an equation, it just is. Yeah. I'm not actually sure about that. You'd have to ask like a math teacher, but we'd probably use is there. At least that's what I've always heard. But really good, perfect answer. Judith, what about the next one?
X squared, or at the second power. Squares.
Nice. Yeah, sorry. S is really close to the D.
Okay.
And what's the 2 called? So what's that number called?
It is the exponent.
Nice. And can you give us an example of an equation using this?
3 squared, or 3 to the second power, equals no. Oh yes, equals 9.
Nice. Perfect. Really good job. Okay. And Vitali, what about the next one?
No. Why the hardest one take to me? This is a function of the function of x.
Yeah. This is the function of x, for sure. Who can make a problem using the function of x?
Julieta?
Okay, x plus 2 equal square root of 25.
I don't know how to do the square root symbol on this thing.
Oh no. Okay, equal 5. Okay.
Thanks. Yeah. Okay.
So x equal 3.
Okay. So I think an example problem might be like if the function of x equals something like 2x. These are tricky. 2x, then like g of x equals 3x plus 1. 3x plus. So if the function of x is 2x, then g of x is 3x plus 1. So with a function of x, we have got like 2 different parts of it, generally. But yeah, I think this is a little bit just like the more basic algebra. But yeah, really good job. Does anybody have any questions here? And Vitali, can you explain your joke?
What joke? What is of the joke? Please.
Oh, come on. You can explain it because that's hilarious. I like it.
What joke? I don't understand you.
Okay, I guess you don't want to explain. You don't have to.
I
That's good
never
though.
joke.
You never joke. You always joke. You're a jokester. Good. Does anybody have any questions here?
No.
Let's skip this. All right, we could read a comic. Let's have Alexander. Can you read the role of Calvin, and Julieta? Can you read the role of Hobbes?
Mhm. Here is another math problem I can figure out. What's 9 plus 4?
Oh, that's a tricky one. You have to use calculus and the imaginary numbers for this.
Imaginary numbers?
You know, 11, 30, 12, and all these. It's a little confusing at first.
How did you learn all this? You've never even go to school.
Instinct tigers are born with it.
Good. Alexander, can you repeat? You've never even gone to school?
You've never even gone to school.
Good. Sounded good. All right. And Vitali, what's happening here?
I don't know. What's the mean 11 change her to 12 and all those? I don't get it.
Okay. Does anybody want to explain what the tiger is talking about here?
He's just saying something confused, numbers that do not exist.
Yeah, he's actually imagining numbers. He's making them up. So they're not like real imaginary numbers, they're imaginary numbers.
Oh, it's like a big Android collider or quantum physics and others.
Or squirrel.
Closing, I think. I thought.
Yeah. So they're imaginary numbers, not real imaginary numbers, which is the funnest thing I've said in a long time. Yeah. And Alexander, do you think you can explain?
Explain what?
The comic. What's happening?
Huh. What's happening? The boy tries to solve the problem and ask for the solution for the tiger.
Yeah. Yeah, sorry, I'm gonna have to cut you off. I do have another class right after this, which I need to start. If you guys want to join, I'd love to have you. But yeah, thanks for coming in. Really great talking to you guys. It was fun. And see you guys soon, hopefully.
Thank you.